All right, this is geometry. Today's date is November 1st. Welcome to November. Hopefully you had a good Halloween. Today we're talking about preserved properties of rigid transformations. Our objective today is to find lengths and angles of images and determine which properties are preserved. So, if I'm talking about a translation, are the angles preserved? And the answer is yes. So, I'm going to say that the angles are congruent. Congruent. And you can think of it, if I have this shape and I translate it up here and I have that same shape, I can try drawing it. It should be exactly the same angles as before. So the angles are still congruent, and that means that angle A is congruent to angle A prime. So the pre-image or the source is congruent to the image. If we think about rotation in terms of the angles, so if I have the same shape, it should still be the same, it just might not be in the same place. So again, we have congruent angles. Congruent, and another way of saying that is you could say like angle B is congruent to, that's supposed to be a squiggly right there, this symbol means congruent to angle B prime. And then same thing for a reflection, the angles are still preserved. I don't randomly change from a shape that looks like this to a shape that looks like that. The angles should still be the same when I do a reflection, so the angles are still congruent. So I can say angle, I can even say this, a different way of saying this is the measure of angle A is equal to the measure of angle A prime. I can use the equal sign instead of the congruent sign because I'm not talking about the angle, I'm talking about the measure, the number of the angle. All right, let's talk about lengths. In terms of the lengths, again, with a translation, I should have the same lengths. I don't randomly have a length that turns into something really long after a translation. So again, I have congruent lengths. And something that you might see like length AB is the same or is congruent to length A prime B prime. You might be seeing a pattern here. They're all gonna be congruent. So we can start doing that right now. Congruent. And through the magical world of technology, I can copy you and paste you and paste you and paste and paste. They're all going to be congruent. The only thing that's going to happen is I'm going to show you a bunch of different examples. Actually, we'll just do examples down here. So area, I could say one area is equal to the other. So there's no notation way of writing that, but you should have like an area of 12. If you find an area of 12 here, it should be equal to an area of 12. Okay, so let's talk about vocab. Rigid transformation. So that's the whole idea of today, properties of rigid transformations. It's also known as an isometry, which is kind of a cooler, fancier word. And it's when the source and the image, and sometimes the source is called the pre-image, it's when the source and the image are, and you might be seeing the pattern here, it's congruent. Again, I can just copy and paste the word congruent, which means you have the same size and the same shape. It might not be facing the same direction. Obviously, if you rotate it or if you reflect it, it might not be in the original place. Translations are pretty straightforward, though. They are usually in the same place. So let's see how to actually use the fact that everything here is still congruent. And this table will be expanded. We'll talk about dilations, and then these things might not necessarily be true, at least in terms of the lengths in the area. Angles we'll talk about. So in example 1, triangle ABC is rotated negative 130 degrees around point P, so there's point P. So this angle, or this triangle, has been rotated negative 130 degrees. That means it's going clockwise 130 degrees to create A prime, B prime, C prime. Don't know what happened there. If I scroll down and up, it fixes it usually. What is the measure of B prime? So if I have B right here and it rotates all the way down here, I still have the same length, which means this is still 56 degrees. So the answer is really straightforward. It's whatever I started with, 56 degrees. There's no tricks. It's always going to be like that. Example number 2, triangle ABC is reflected across line M to create A prime, B prime, C prime. What is the area of ABC? So I'm looking at this triangle right here. I need to find its area. Luckily, I have a right triangle, but I need to find this length right here. Oh, I can find that length. That length is the same length as this length. AC is the same length as A prime, C prime. So this length right here is 3. And then I can find the area. The area of a triangle is 1/2 base times height. So it's going to be 1/2, 3 times 4, 3 times 4, and half of 12 is 6. So it's going to be 6 units squared. What about the perimeter of A prime, B prime, C prime? So again, we have 5, 3, and we're missing that length. If I had that length, then I could just add them all up. Oh, well, I had that length. It's right here, 4. I can put that point right here, 4, or this length right here. 4 plus 5 is 9, 9 plus 3 is 12, so 12 units. So you're always borrowing angles, you're borrowing, I don't know why I did a circle there. You're borrowing angles, you're borrowing lengths, going back and forth. They're always the same length, the same angles. Let's talk about example number 3. We have another triangle ABC, and we're saying that if I'm getting to the image A prime, B prime, C prime, that is the result of reflecting triangle ABC across line N. And in Khan Academy, they do give you space to see what that looks like. You don't actually have to perform the reflection though. So you're only supposed to answer the following questions, and this is our final example. It's saying that AB, line segment AB and line segment A prime, B prime are both perpendicular to the y-axis. Well, is that still true? Is that an unchanged property between triangle ABC and triangle A prime, B prime, C prime? And we're choosing all that applies, so it might be A, B, and C, or maybe just D. So let's think about this. If I have AB, it does look like it's perpendicular to the y-axis. It does make this 90-degree angle right here. So that seems to be true with AB. But what about A prime, B prime, this line segment down here? And it's kind of hard to see, but if I reflect this, I go 1.5. So I'm really going 1.5 diagonals. I'm counting diagonal units. That means I'm going another 1/2 and then 1. Remember, it has to go at a right angle, so it is going through the diagonals in this case. And it has to go the same distance, so that is my new A prime. And then again, going through the diagonals, 1, 2, 3.5. There's a half, and I need to go 1, 2, 3 more. 1, 2, 3. And there is my B prime. You don't need to know how to reflect over a diagonal line, but you should be able to approximate what's going to happen in your mind, and this is me showing you what's actually happening. You can see that this line segment A prime B prime is now not perpendicular to the y-axis, it's perpendicular to the x-axis, which is kind of interesting. So it's actually not A, it's AB, line segment AB is perpendicular to the y-axis, but a line segment A prime B prime is perpendicular to the x-axis. If I continue this line, it would have been a right angle right there. Moving on, C and C prime have the same measure. So it's talking about, and this is kind of an error, I should be saying angle C and angle C prime. Remind me to give you all 70xb. That's kind of a typo. Angle C and angle C prime, if it's talking about the measure, it's talking about some angle. So I'm looking at C right up here and C prime. Well, we know that angles are preserved, so this angle should also be preserved. That's definitely one of the right answers. Let's circle that one. And the areas of ABC and area of A prime, B prime, C prime are the same. Well, we know that areas are also preserved because up here we know that angles are all congruent with rigid transformations. So I can come down here and say, okay, well that's obviously true. Whenever you have something that is talking about line segments being perpendicular or their positioning, then it might not be true. But if you're just talking about their angles, their lengths, or their areas, they are always going to be congruent to each other. So the correct answer here is B and C, but not A, and obviously not D. All right, that's the end of the notes. Please work on Khan Academy. I'll see you guys on Monday.